Right now, as you listen to this, particles from deep space are passing through you, trillions of them, every second, streaming down from the sky, sailing through your body, through the floor, through the ground, slipping between the atoms of everything you have ever known without leaving a trace. This is normal. This is the universe doing what it always does, raining its invisible fragments down upon us from above. Down, always down. From the sky, through the world, and onward into the deep. But twice, high in the freezing air above the most desolate place on Earth. An instrument built to watch the sky caught something coming the wrong way. Something came up out of the ice, up out of the solid ground. A burst of energy that, by every rule we understand, should have traveled down from the heavens like everything else, but instead came climbing up from beneath, as though it had passed all the way through the entire planet. 8,000 miles of solid rock and molten iron and crushing pressure, and emerged on the far side, in Antarctica, pointing at the stars. And here is the part that made physicists go quiet. According to our complete and exhaustively tested theory of how reality works, the particle that did this cannot exist. What Anita saw should not have been possible. And to this day, no one is certain what it was. Tonight, we are going to walk into one of the strangest unsolved mysteries in modern physics books. A mystery that hides at the very edge of what we are able to detect, in signals so faint and so rare that only a handful of them have ever been seen. And that has divided the world's physicists into uneasy camps, none of whom can fully explain what happened. We are going to learn what is supposed to come down through the sky and why. We are going to learn how a strange experiment, dangling from a balloon at the edge of space over the frozen bottom of the world, accidentally caught something coming up instead of down. We are going to understand exactly why that direction, up, is so deeply, profoundly wrong. Why it breaks the rules so badly that it should simply not be allowed to happen. We are going to follow the desperate search for an ordinary explanation and watch the ordinary explanations struggle. And we are going to confront the genuinely disturbing possibility that has lingered over this whole affair from the beginning. The possibility that we have caught a glimpse of physics we do not understand, a particle not in any of our books, a crack in the foundation of everything we think we know about what reality is made of. This is not a fringe claim made by people on the edges of science. The instrument that caught these events was a serious NASA-supported experiment, built and flown by respected physicists, designed and operated with care. The events were not dismissed by the people who recorded them, nor were they hyped into a certainty. They were reported honestly, scrutinized intensely, debated in the scientific literature for years, and they have never been cleanly resolved. That is what makes them worth an entire night of attention. This is not a ghost story dressed up as science. It is real science confronting a real anomaly, a genuine signal that genuine experts cannot fully explain, sitting in the published record like a splinter no one has been able to remove. And the longer it sits there unremoved, the more it forces a question that grows harder to avoid the more carefully you think about it. What do you do when your best, most trusted, most exhaustively tested description of reality says, a thing is impossible, and then the universe appears to do that thing anyway? More than once, in front of an instrument you built specifically to watch it, but before we can understand why something coming up is so terrifying to a physicist, we have to understand what is supposed to come down, and why the universe has been raining its secrets onto our heads since long before there was anyone here to notice. Space is not empty, and it is not quiet. Out there, in the violent engines of the cosmos, in exploding stars, and the hearts of distant galaxies and forces we do not fully understand, particles are being flung outward at almost the speed of light, hurled across the universe with staggering energy. They travel for thousands or millions of years through the dark, and a steady rain of them falls upon the earth from every direction, every moment of every day. We call them cosmic rays, though they are not rays at all, but particles, fragments of atoms, single protons, and heavier nuclei, moving so fast that a single one of them can carry the energy of a thrown ball compressed into something smaller than a speck of dust. They have been falling on this planet for its entire existence, an invisible weather of the cosmos, and we live our whole lives beneath this gentle, ceaseless bombardment without ever feeling a thing. When one of these cosmic ray particles slams into the top of our atmosphere, it does not simply pass through. It hits an atom of air with tremendous force, and that collision shatters both particles into a spray of new ones, which fly onward and hit more atoms, shattering into still more, in a cascade that grows and spreads as it falls. A great expanding shower of particles raining down through the sky. A single cosmic ray striking the top of the atmosphere can produce billions of secondary particles by the time the shower reaches the ground, spread across an area the size of a city. This is called an air shower, and it is one of the most important things in this whole story, because an air shower is not silent. As all those charged particles sweep downward through the atmosphere, they give off a faint flash of radio waves, a brief electromagnetic whisper, the radio signature of the cascade. And if you build an instrument sensitive enough, you can hear that whisper, and from it reconstruct the particle that started it all, falling from the sky. This is what physicists wanted to do, and it is why they went to Antarctica, because there is another, even more elusive messenger from space that they were truly hunting for. A particle so shy, so reluctant to interact with anything, that catching it requires the most extreme measures. That particle is the neutrino. And to understand the entire mystery, you have to understand just how strange and ghostly the neutrino is. Because the neutrino is the only thing in all of physics that should be able to pass through the Earth at all. And even the neutrino, as we will see, should not have been able to do what Anita saw. The neutrino is the closest thing the universe has to a ghost. It is one of the most abundant particles in all of existence, produced in staggering numbers by the sun, by exploding stars, by the violent events that fill the cosmos. Right now, about 100 trillion of them are passing through your body every single second, and you feel nothing, because the neutrino almost never interacts with anything. It has no electric charge. It is almost without mass. It ignores the matter it passes through as though that matter were not there at all. A neutrino could pass through a wall of solid lead, a light year thick, and have only a fair chance of being stopped. They stream out of the sun and pour straight through the entire Earth and out the other side, unhindered, billions upon billions of them, as if the planet were made of empty air. This is what makes the neutrino so precious to physicists and so maddening. Because it interacts so rarely, a neutrino can travel across the universe in a straight line, carrying pristine information about the violent place that made it, unlike the cosmic ray particles that get bent and scattered along the way. But because it interacts so rarely, it is almost impossible to catch. To detect even a handful of them, you need an enormous amount of material and a great deal of patience, waiting for the vanishingly rare moment when one of these ghosts happens, by sheer chance, to strike an atom and reveal itself. The reward for this enormous patience is something genuinely new in the history of human knowledge. A way of seeing the universe that has nothing to do with light. For the entire history of astronomy, we have studied the cosmos by gathering light, the visible glow of stars, then the invisible bands beyond it, radio and infrared and X-rays. But light has limits. It can be blocked, absorbed, scattered. It cannot easily escape the dense hearts of the most violent objects, the cores of exploding stars, the engines at the centers of galaxies, the places where the most extreme physics happens. Neutrinos can. Because they interact so rarely, they stream straight out of those hidden, violent cores and travel across the universe in undeviating lines, carrying pristine news of the most cataclysmic events in existence, news that light itself cannot bring. To catch a neutrino from a distant cosmic catastrophe is to receive a message from a place no telescope can ever see into, a direct line to the most violent furnaces in the universe. This is the dream that drives the whole enterprise. The dream of neutrino astronomy, of seeing the cosmos through its ghosts rather than its light. And it is a dream that has begun to come true. In recent years, neutrino detectors have caught particles arriving from specific violent objects across the cosmos, pinting their sources, opening a genuine new window on the universe, a window that does not use light at all. We are learning to listen to the universe in a new sense, to feel the passage of its ghosts, to read messages written in the one particle that can escape from anywhere and pass through anything. It is one of the most exciting frontiers in all of science, the birth of a new kind of astronomy, and the instruments built to pursue it, the great buried detectors and the balloon-borne antennas drifting over the ice, are the first crude eyes of a sense we are only beginning to develop. Anita was one of those first eyes, straining to catch the faintest, highest energy ghosts of all, the ones carrying the most extreme energies the universe can produce. And in straining to see them, it caught something it was never looking for, something coming from the wrong direction entirely. And this is why physicists went to the bottom of the world. Because Antarctica has in its vast ice sheet one of the largest, cleanest, most transparent blocks of solid material on the entire planet. Miles of pure, ancient ice stretching for thousands of square miles, radio quiet, far from the electrical noise of civilization. If a high-energy neutrino were to strike an atom deep within that ice, the collision would produce a brief, sharp flash of radio waves, spreading outward through the ice. And so an experiment was designed to listen for exactly that. They called it Anita, the Antarctic Impulsive Transient Antenna. And it was one of the more audacious instruments ever flown. Rather than burying detectors in the ice, Anita was lifted high above it, hung beneath an enormous balloon, and floated up to the edge of space, nearly 40 kilometers above the surface, higher than any aircraft flies. drifting in the thin, cold air at the top of the world. From that great height, Anita could gaze down upon an enormous expanse of ice all at once, a vast frozen antenna, listening for the faint radio flashes of neutrinos striking the ice far below, or for the radio whispers of cosmic ray air showers cascading down through the atmosphere. For the most part, Anita did exactly what it was built to do. It drifted above the ice for weeks at a time, circling the pole on the polar winds, listening, recording the faint radio signals of the cosmos. And among the signals it caught were the air showers, the cascades of cosmic ray particles falling down through the sky. These were expected, well understood, and they carried a particular signature, a kind of fingerprint, that is going to matter enormously for the rest of this story. So pay close attention to it, because this fingerprint is the entire key to the mystery. When a cosmic ray air shower cascades downward through the atmosphere and Anita detects its radio flash, the signal can reach the instrument in two ways. Sometimes, the radio waves travel directly upward from the descending shower to the balloon, and sometimes the radio waves travel downward first, bounce off the surface of the ice below, and then reflect back up to the balloon. These two paths produce signals that look almost identical, with one crucial difference. When a radio wave reflects off the ice, the reflection flips it. The wave is inverted, turned upside down, its peaks becoming troughs and its troughs becoming peaks. In the same way, your reflection in a mirror is reversed. This inversion is a known, reliable, unavoidable consequence of bouncing off a surface. So when Anita sees a signal that has been flipped, inverted, it knows that signal reflected off the ice, which means the shower that produced it was coming down from above, as a cosmic ray shower always should. The inversion is the signature of reflection, and the reflection is the signature of something coming down. Downgoing showers bouncing off the ice arrive flipped. This is the rule. This is what the data always showed, until twice it didn't. In the data from two separate flights, years apart, Anita recorded something that broke the rule. It caught radio signals that had every appearance of an air shower, the same kind of cascade of particles, the same kind of radio flash. But these signals were not inverted. They were not flipped. They had not bounced off the ice, and yet they were coming from below, from the direction of the ice, climbing upward toward the balloon. A signal that comes from below but is not inverted has only one possible meaning, and it is a meaning that should be impossible. It means the air shower was not coming down and reflecting. It means the air shower was going up. It means a particle had come up out of the ice, out of the earth itself, and was cascading upward into the sky, producing a radio flash that traveled directly to the balloon without ever bouncing off anything, which is why it was not flipped. The shower was not a reflection of something falling. It was the real thing, rising. Let that sink in, because the people who first saw it could hardly believe it. An air shower is what you get when a high-energy particle from space slams into matter and cascades. A downward air shower is ordinary, expected, the daily weather of the cosmos. But an upward air shower means that a high-energy particle came up from inside the Earth, emerged from the ice, and cascaded into the air above it. The particle was not falling from the sky. It was rising from the ground. And to rise from the ground in Antarctica, it had to have come up from beneath the ice, which meant it had have come from inside the planet. which meant it had to have traveled through the Earth to get there. Stop and picture the geometry of it, because the picture is what makes it real. The balloon hangs near the top of the atmosphere, looking down. The signal arrives climbing upward toward it, from below, from the ice. Trace that path backward, down past the surface, and it does not stop at the ice. It plunges into the rock beneath and keeps going, down through the crust, down through the deep interior, through thousands of kilometers of solid and molten material under pressures that would crush anything we could build, and out the far side of that vast cord, through the body of the planet, all the way back to wherever the particle entered on the opposite face of the Earth. That is the journey the signal demands. Not a particle that grazed the surface, not a particle that came from just below the horizon, but a particle that entered the Earth on one side, drove straight through the planet's deep interior, and merged on the other in Antarctica, still carrying enough energy to slam into the air and start a cascade. The Earth, the whole enormous bulk of it, sat in the path like the thickest wall imaginable, and the particle went through it as if the wall were not there. And it was not a gentle, glancing path either. When the physicists worked out the angle of the signal, they found that these upward events were arriving at a steep angle, climbing up from well below the horizon. This is crucial, because the angle tells you how much of the Earth the particle had to pass through. A particle skimming up from just below the horizon only has to cross a thin sliver of the planet's edge, but a particle arriving at a steep angle from far below the horizon has to cross a vast amount of the Earth's interior. Thousands upon thousands of kilometers of rock, possibly even passing through regions near the dense core. The steep angle of the Anita events meant that whatever produced them had bored straight up through a tremendous thickness of solid planet, thousands of kilometers of rock, before bursting out of the ice in Antarctica and cascading into the sky. It had treated the Earth, the entire enormous mass of our world, as though it were a window, and it had done so carrying an almost unimaginable amount of energies in the range where, by everything we understand, no known particle should be able to make that journey at all. This is the heart of the impossibility, and to feel its full weight, you have to remember what we said about how matter blocks things. Almost nothing can pass through the Earth. Light cannot. Cosmic ray particles cannot. They are absorbed in the first sliver of atmosphere. The only thing in all of physics that can routinely pass through the entire planet is the neutrino, the ghost particle, precisely because it interacts so rarely. So at first glance, you might think, well, there is. Your answer, it was a neutrino. Neutrinos pass through the Earth all the time. But here is the cruel twist that turns this from a curiosity into a genuine crisis. The events Anita saw were at extraordinarily high energy, and the strange, counterintuitive truth about neutrinos is that the higher their energy, the less ghostly they become. A low-energy neutrino sails through the Earth without noticing it, but a very high-energy neutrino, the kind that would produce a signal like Anita's, interacts far more readily, far more easily absorbed by matter. And at the colossal energies of the Anita events, a neutrino traveling through thousands of kilometers of rock should be absorbed, swallowed by the Earth, long before it could emerge on the other side. The Earth, to a neutrino of that energy, is not a window. It is a wall. So the one particle that could normally pass through the planet should not have been able to make this particular journey either. Whatever came up through the Earth and burst out of the Antarctic ice was something that, by our complete theory of the particles and forces of reality, should not have made it through. And yet, twice something did. It is worth dwelling on just how few of these events there were, and how much energy they carried, because both facts deepen the puzzle. Anita flew over Antarctica several times across the years, drifting above the ice for weeks on each flight, recording mountains of data. In all of that watching, across all those flights, the anomalous upward events that have caused all trouble number, only a small handful, recorded years apart on separate flights. They are rare, isolated, scattered across more than a decade of observation. This rarity cuts both ways. On the one hand, it means we cannot study them in bulk, cannot gather statistics, cannot easily characterize them, because there are simply too few. Each one is a precious, isolated data point, pored over endlessly. On the other hand, the rarity makes them harder to dismiss as ordinary, because if they were some common reflection effect, you would expect to see them constantly, not twice in a decade. And the energy is staggering, and it is central to the whole impossibility. These were not gentle, low-energy particles. The signals corresponded to particles carrying energies in a range that beggars the imagination for a single subatomic object. Energies vastly higher than anything our most powerful machines on Earth can produce, the kind of energy that exists only in the most violent processes in the cosmos. A single of these particles carried, packed into something unimaginably tiny, an amount of energy you would associate with a macroscopic object. A thrown ball, a swung fist, concentrated into a speck far smaller than an atom. It is at exactly these colossal energies that the cruel trap snaps shut, because, as we will see, the higher the energy of a neutrino, the more readily it is absorbed by matter. And so it is precisely the enormous energy of the Anita events that makes their passage through the Earth so impossible. A low-energy ghost could have slipped through the planet easily, but these were not low-energy ghosts. They were among the most energetic particles ever associated with anything passing through the Earth, and that is exactly why they should have been stopped. There is a strange beauty in the precision of the contradiction. It is not vague. It is not a matter of someone simply being puzzled. It is a sharp, quantifiable impossibility. Take the energy of the events. Calculate how far a neutrino of that energy can travel through rock before being absorbed. Compare it to the thickness of Earth, the steep angle required the particle to cross. And the numbers do not merely fail to match. They fail catastrophically by enormous margins. The particle should have been stopped, not with some small probability, but with near certainty, swallowed by the planet long before reaching the far side. To emerge anyway is not to beat slightly unfavorable odds. It is to do something that our physics says should essentially never happen. And it happened, apparently, more than once. It is worth slowing down here, because the impossibility is the whole point, and the more precisely you understand it, the more unsettling it becomes. Imagine you are firing bullets into an enormous block of some material, and you want to know how far they get before they stop. If the material is soft, the bullets travel far. If it is dense, they stop quickly. Physicists describe this for particles with a quantity that amounts to how thick a wall of matter a particle can typically punch through before it is stopped, a kind of penetration depth. For a low-energy neutrino, this penetration depth is astronomical, light years of solid matter, which is why it sails through the Earth without trouble. But this penetration depth shrinks as the neutrino's energy climbs. The more energetic the neutrino, the more eagerly it interacts, and the shorter the distance it can travel through matter before being absorbed. At the tremendous energies of the Anita events, the penetration depth of a neutrino shrinks dramatically until it becomes far smaller than the thickness of rock the particle would have had to cross to make that steep upward journey through the Earth. In plain terms, a neutrino of that energy, fired into the Earth at that steep angle, should have been absorbed somewhere along the way, swallowed by thousands of kilometers of rock, with essentially no chance of emerging on the far side. The odds against it making the trip are not small. They are crushing. Try to feel the scale of that with an image. Imagine the Earth not as a planet, but as an enormous, dense fog bank, thousands of miles thick. And imagine you are trying to throw a stone all the way through it and out the other side. A small, light stone, thrown gently, might drift a long way through a thin mist. But for these particles, the rule is inverted in the cruelest way. The harder the throw, the thicker the fog becomes, until a stone thrown with tremendous force is stopped almost at once. It's very energy what makes it interact so strongly and stop so fast. The Anita particles were stones thrown with colossal force, the kind of energy that, for a neutrino, turns the Earth from a thin mist into a thick and clinging fog that should have swallowed them whole within a tiny fraction of the journey. And yet the stone came out the far side, having climbed up through thousands of miles of the densest fog and burst into the air over Antarctica as though the fog had simply parted. By the rules we know, that should not happen. The very energy that should have guaranteed the particle's absorption is the energy with which it apparently sailed clean through the entire planet. That is the inversion at the heart of the whole mystery, the cruel little twist that turns a routine ghost into an impossibility. The more powerful the particle, the more surely the Earth should have stopped it. And yet, the most powerful particles of all are exactly the ones that somehow came through when they had every reason in physics to be stopped cold. This is what makes the anomaly so much more than a curiosity. A particle doing something merely surprising is the daily business of physics. But a particle is doing something that the most precise and successful theory in the history of science declares to be essentially impossible, and doing it more than once is a different order of strangeness. It is the kind of thing that, if it is real, does not get added as a footnote to the theory. It breaks the theory open. It says that our complete catalog of the particles and forces of nature, the framework we have tested to a dozen decimal places, is missing something, that there is a particle or a process or a piece of physics we have never seen quietly making the impossible happen at the bottom of the world. That is the stakes of it. Either the ice fooled the balloon or the rule book is incomplete. There is very little comfortable ground in between. So we are left with a genuine paradox, and it has a very specific shape. The thing that produced the Anita signal behaved like a particle that passed up through the Earth and burst out of the ice to make an air shower. the only known particle that can pass through significant amounts of the Earth at all is the neutrino. But at the energy of the Anita events, a neutrino should not have been able to pass through that much of the Earth, because at high energy neutrinos are readily absorbed. So, the events look like they were made by a neutrino, but they cannot have been made by an ordinary neutrino, because an ordinary neutrino of that energy could not have survived the journey. Every door leads back to the same locked room. The signal demands a particle that passed through the Earth. Our physics says no known particle that could make that signal could also have made that passage. The two requirements contradict each other, and contradiction in physics is not a small thing. It is the sound of a theory hitting its limit. It is worth being precise about why this particular contradiction is so airtight, because that is what elevates it from a puzzle to a genuine crisis. The argument has no obvious escape hatch. You cannot say the particle was some other known thing, because no other known particle can cross any significant amount of the Earth at all. Only the neutrino can, and barely. You cannot say it was a low-energy neutrino that slipped through easily, because the signal was unmistakably high energy, and high energy is exactly what dooms a neutrino's passage. You cannot say it skimmed the thin edge of the planet, because the steep angle says it bored through thousands of kilometers of rock. Every loophole you reach for slams shut. The known physics allows exactly one kind of particle to attempt the journey, forbids that particle from completing it at the observed energy, and leaves no third option on the table. That is what a real contradiction looks like. Not a vague tension, but a tightly closed box, where every door you try leads back to the same impossibility. And when a box closes that tightly around an observation, you are left with only two ways out. Either the observation is somehow not what it appears to be, or the physics that built the box is incomplete. There is something deeply unnerving about a particle that comes from the wrong direction. We are used to threats and signals coming from out there, from the sky, from above, from the great dark spaces of the cosmos. The whole architecture of our intuition about space is built on the idea that the universe is up and the ground is down, that the dangers and mysteries of the heavens rain down upon us from above, while the solid earth sits safe and impenetrable beneath our feet. The Anita events invert that intuition. They are messages from below, climbing up out of the ground we trust to be solid, emerging from beneath the most solid, most permanent, most reassuring thing in our entire experience, the planet itself. There is a primal wrongness to it. The feeling you might get if you knocked on a solid wall and heard a knock answer back from inside. The Earth is supposed to be a barrier. It is supposed to stop things. And twice, something came up through it as though it were not there, carrying an energy that should have made it impossible, and burst into the thin, cold air above the ice, and vanished, leaving behind only a faint radio whisper and a question that physicists have been unable to answer. And it is not as though they have not tried. The discovery of these anomalous events set off years of intense effort, because a result like this cannot simply be accepted. Extraordinary claims demand extraordinary scrutiny, and the claim that something is passing up through the Earth in ways our physics forbids is about as extraordinary as it gets. So, the first and most responsible thing physicists did was to assume that the answer must be something ordinary. something they had overlooked, some mundane effect that could mimic an impossible upward particle without requiring any new physics at all. The hunt for that ordinary explanation has been long and ingenious. And it is a crucial part of the story. Because if the mystery could be explained away, it would be. The fact that it has resisted so many attempts is exactly what keeps it alive. And there is a peculiar pressure in that resistance, the longer it lasts. With each careful study that fails to dissolve the anomaly, the stakes quietly rise. An anomaly that is explained away in a month is forgotten in a month. But an anomaly that survives a year of scrutiny, and then another, and then several more, each attempt to bury it, leaving it stubbornly standing, begins to take on a weight that a fresh puzzle never has. It accumulates significance simply by enduring. Every loose cable that was checked and found tight, every mundane mechanism that was proposed and found wanting, adds to the strange gravity of the thing until it becomes not just one more curiosity in the vast catalog of open questions, but a genuine landmark, a fact that the field cannot stop circling back to. The Anita events have now survived that gauntlet for years. They are still standing, and the fact that they are still standing after everything thrown at them is precisely why we are still talking about them, and why physicists are still building new instruments to chase them down. Most anomalies do not earn that kind of attention. This one has by refusing again and again to go quietly away. The most natural, ordinary explanation goes right back to that crucial fingerprint, the inversion. Remember, a signal that has reflected off the ice is flipped, and a signal that has not reflected is not flipped. And the Anita events were not flipped, which is why they looked like they came directly from below, rather than bouncing off the surface. But what if there were some way for a signal to reflect or to be produced near the surface without getting flipped? What if the ice itself, which is not a simple flat mirror, but a complex, layered, ancient structure with buried surfaces and density changes and strange features deep within it, could under some circumstances bounce or bend a radio wave in a way that did not invert it? If a perfectly ordinary downgoing cosmic ray shower produced a radio flash that interacted with some unusual feature of the ice and arrived at the balloon without the expected inversion, it would masquerade as an impossible upward event while being nothing of the sort. The whole anomaly would dissolve into a quirk of how radio waves behave in Antarctic ice. This is a serious and reasonable idea, and a great deal of work has gone into exploring it. The Antarctic ice sheet is not uniform. It has layers laid down over hundreds of thousands of years. It has regions of different density, buried crevasses, subsurface structures, and a transition zone near the top where loose snow gradually compacts into solid ice. Radio waves passing through and reflecting within this complex medium can do subtle and surprising things. Researchers have proposed that under certain conditions, reflections off particular subsurface features or off unusual patches of the surface could fail to produce the standard inversion, or could produce signals that mimic the appearance of an upward shower. Others have explored whether some form of radiation produced as particles cross the boundary between different materials, a known effect, could generate a confusing signal near the surface. The general thrust of these efforts is to find a way for something ordinary and down to leave a fingerprint that looks impossible and upgoing, without invoking any new physics. The ice, it turns out, is a far more complicated mirror than anyone might assume. Near the surface, it is not solid ice at all, but a deep layer of compacted snow, so that a radio wave passing into it does not meet a single sharp boundary, but a gradual transition, which can bend and split and reshape the wave in subtle ways. Beneath that lie buried layers, ancient surfaces, regions where the ice changes character, each one a potential reflector. There are places where the underlying rock rises close to the surface, places where subsurface water or unusual structures lurk, places where the geometry of the terrain could channel a reflection in unexpected directions. A radio wave bouncing through this complex, layered, imperfect medium can do things that a simple, flat mirror model would never predict. And somewhere in that complexity, the argument goes, may lie a way to produce a signal that mimics an upward shower without one ever having occurred. Researchers have built elaborate models of the ice, run simulations, studied how radio waves actually behave in the Antarctic environment, all in an effort to find the loophole that would let an ordinary downgoing cosmic ray masquerade as an impossible upward particle. And some of this work has been genuinely promising. Certain analyses have suggested that under the right circumstances, the strange properties of the ice or the surface could indeed produce confusing signals. And as the understanding of Antarctic radio propagation has improved, the mundane explanations have grown somewhat stronger, enough that many physicists now lean toward the view that the events will ultimately prove to be some such effect. But promising is not the same as proven, and leaning toward is not the same as demonstrating. No one has yet been able to take a specific, well-understood ice or surface effect and show conclusively that it produced these particular events with all their particular characteristics. The mundane explanation remains a strong candidate, perhaps the leading one, but it remains a candidate, not a verdict, and that crucial gap between likely and proven is exactly the space in which the mystery continues to live. But here is why the mystery has not simply been put to rest. For all the cleverness of these proposed explanations, none of them has cleanly and completely accounted for the events. Each proposed ordinary mechanism tends to explain some features while struggling with others, or requires conditions that are themselves unusual or unlikely, or fails to match the detailed characteristics of the actual signals. The events were, by the careful analysis of the people who study them, difficult to dismiss. They did not look like the ordinary reflections that Aneta saw all the time, the ones that were properly flipped. They looked stubbornly like genuine upward showers, and so the situation settled into an uneasy stalemate. On one side, the reasonable conviction that the answer must be some subtle, some mundane effect, some trick of the ice or the instrument, because the alternative is too radical to accept lightly. On the other side, the stubborn refusal of the evidence to be neatly explained by any of those mundane effects, leaving the door to something stranger, propped uncomfortably open. There is a deep tension in this kind of science, and the Aneta an anomaly sits right in the heart of it. On the one hand, you must not leap to exotic explanations, because the history of physics is littered with anomalies that turned out to be instrumental errors, loose cables, miscalibrations, subtle effects that were eventually understood and that required no new physics at all. The responsible scientist assumes the boring explanation until forced to abandon it. On the other hand, you must not be so committed to the boring explanation that you explain away a genuine discovery. Because the history of physics is also full of anomalies that everyone assumed were errors, and that turned out to be the first signs of something revolutionary. The art is in holding both possibilities at once, taking the anomaly seriously enough to investigate it fully without taking it so seriously that you abandon caution. And the Anita events have lived in that uncomfortable middle ground for years, too strange to dismiss, too uncertain to celebrate, a signal that might be a quirk of Antarctic ice or might be a crack in the foundations of physics, with no one able to say for certain which. The caution is not misplaced, because the history of physics is full of thrilling anomalies that turned out in the end to be mistakes, and the people who got burned by them learned to be careful. There is a famous example from not so long ago, when an experiment appeared to measure neutrinos traveling faster than light, a result that, if true, would have overturned the foundations of modern physics, shattered the cosmic speed limit, and rewritten our understanding of space and time. For a brief electric period, the world wondered if the impossible had happened. The physicists involved were careful, competent, and genuinely puzzled, and they did the responsible thing, announcing the anomaly and inviting the world to scrutinize it. And after intense investigation, the answer turned out to be heartbreakingly mundane. A loose fiber optic cable and a timing error in the equipment. There was no faster-than-light travel. There was a faulty connection. The revolution dissolved into a maintenance issue. That story hangs over every anomaly in physics like a cautionary ghost, and it should. It is a reminder that the universe is subtle, that instruments are imperfect, that the gap between a measurement and reality is full of opportunities for error, and that the more revolutionary a result would be, the more certain you should be that it is not simply a loose cable before you let yourself believe it. Extraordinary claims, as the saying goes, require extraordinary evidence, and a handful of strange signals, however resistant to explanation, do not yet rise to that bar. The responsible physicist looking at the Anita events keeps that faster-than-light ghost firmly in mind and assumes, until proven otherwise, that the answer will turn out to be some equivalent of a loose cable, some subtle effect of the ice or the instrument that, once understood, will make the impossible ordinary again. And yet, the same history that warns us about loose cables also warns us not to be too sure. For every anomaly that dissolved into an instrumental error, there is another that everyone assumed was an error, and that turned out to be real. The trick, the genuinely hard part, the thing that separates great science from both gullibility and closed-mindedness, is that you cannot tell which kind of anomaly you have until you investigate it thoroughly. The faster-than-light neutrinos looked exactly as exciting, at first, as a real discovery would have. The only way to know was to chase it down, find the cable, and settle it. The Anita events are being chased down in exactly the same spirit. And the honest truth is that they have not yet been settled, that no one has found the equivalent of the loose cable, and that until someone does, or until a new instrument gathers enough data to decide, the question remains genuinely, maddeningly open. The ghost of the loose cable says it is probably mundane, The stubborn persistence of the events says, maybe not, and both voices are speaking at once. And then, as if the puzzle were not difficult enough, another experiment, a giant detector buried in the very same Antarctic ice, made the mystery worse. Because if the Anita events were caused by some new kind of particle streaming through the Earth, that detector should have seen evidence of it too. And it didn't. Deep in the Antarctic ice, not far from where Anita drifted overhead, sits one of the largest and most sensitive instruments humanity has ever built for catching neutrinos. It is a vast detector, a cubic kilometer of ice, instrumented with thousands of sensitive optical sensors lowered into holes, melted deep into the ice sheet, watching constantly for the faint flashes of light produced when a neutrino strikes an atom in the ice. It has been running for years, and it has caught more high-energy neutrinos than any instrument in history, mapping the neutrino sky, detecting ghostly particles from across the cosmos. It is, in short, exactly the instrument you would want to consult if you wanted to know whether there really is a flux of strange, Earth-traversing particles arriving at the South Pole. And so, naturally, physicists asked it. To appreciate the weight of what this detector's silence means, you have to understand its scale. It is not a modest instrument. It is a cubic kilometer of ice turned into an eye, thousands of sensors strung on long cables lowered into holes drilled more than a mile deep into the ancient ice sheet. A detector so vast it is measured in the billions of tons of ice it watches. It has been running continuously for years, gathering an enormous exposure, watching far more ice for far longer than Anita ever could from its brief balloon flights, where Anita glanced down at the ice for weeks at a time. On occasional flights, this detector stares unblinkingly, year after year, into the heart of the ice itself. If there is any steady population of high-energy particles arriving at the South Pole and interacting in or near the ice, this is the instrument that should see it most clearly, in the greatest numbers, with the least ambiguity. It is the natural authority to consult, the most sensitive witness available, watching the very same frozen ground from which Anita's impossible signals appeared to rise. That is what makes its silence so loud. It is not that some small, marginal detector failed to confirm the events. It is that the largest, most sensitive neutrino detector ever built, watching the same region for years, found no trace of the companion events that any real flux of Earth-crossing particles would have to produce. The mismatch is stark and quantitative. To produce even the handful of events Anita saw, given how little Anita watches, there should be a substantial flux of these particles, and that flux should have lit up the buried detector with a clear population of related events. Instead, that detector reports nothing of the kind. The arithmetic of the two instruments simply does not reconcile under any straightforward explanation. A real flux would have shown up in both. An instrumental quirk would have shown up in neither in this peculiar way. The events sit in an impossible middle, present where they are hard to explain and absent where they should be obvious. The logic is straightforward and damning. If the Anita events were caused by some particle, known or unknown, that can pass up through the Earth at those energies, then such particles should not be arriving one at a time in total isolation. Whatever cosmic source is producing them should be producing many, a whole flux of them raining onto the earth and passing through it. Anita, for all its cleverness, watches only a limited patch of ice for limited stretches of time. So, for it to have caught even two such events, there should be a substantial population of these particles streaming through the planet. And if that population exists, then the giant detector buried in the ice, which is far more sensitive to such things over far longer periods, should have caught a whole shower of related events, dozens of them, a clear and unmistakable signal. The buried detector should have seen the corroborating evidence, the supporting cast that any real flux of Earth-crossing particles would have to bring with it. It saw nothing. The giant detector searched its years of data for the kind of events that would have to accompany the Anita anomaly if it were caused by real Earth-traversing particles, and it found no such signal. The supporting evidence simply was not there, and this absence is, in its own quiet way, as troubling as the original anomaly, because it deepens the contradiction rather than resolving it. If Anita saw real particles passing through the Earth, the buried detector should have seen many more, and it did not, which makes it even harder to explain the Anita events as any kind of straightforward particle, known or unknown, arriving in a normal flux from space. The numbers do not fit together. Two events here, where there should be few, and zero events there, where there should be many. The two instruments, watching the same patch of frozen world, tell stories that cannot both be true under any simple explanation. This is the kind of tension that physicists find genuinely maddening, because it closes off the easy answers from both directions. The mundane explanations, the tricks of the ice, struggle to fully account for the strange appearance of the events. But the exotic explanations, the idea of real particles passing through the Earth, struggle just as hard. Because if those particles were real and arriving in any normal way, the other detector should have seen their companions. The anomaly is squeezed from both sides. It is too strange to be easily mundane, and too lonely to be easily exotic. It sits in a gap between explanations, refusing to fit comfortably into either. And that refusal is precisely what has kept physicists arguing about it for years without resolution. And so, having exhausted the easy answers, some physicists began to consider the harder ones, the genuinely radical possibilities, the explanations that would require us to add something new to our picture of reality. Because if the events are real, and they are not ordinary neutrinos, and they are not simple tricks of the ice, then perhaps they are something we do not yet have in our theories at all. Perhaps Anita caught a glimpse of physics beyond the edge of the known, a particle or a process that is not in any of our books. And these ideas, speculative and unproven as they are where the mystery becomes not just puzzling but profound. To understand the exotic possibilities, you have to understand what physicists mean when they talk about the limits of their current theory. We possess a description of all the known particles and forces of nature, an extraordinarily successful framework that has predicted the outcomes of countless experiments with breathtaking precision. It is one of the crowning achievements of human thought, but it is also known to be incomplete. It does not include gravity in the way it includes the other forces. It says nothing about the dark matter that we know dominates the universe. It leaves deep questions unanswered. Physicists are certain there is more to reality than this framework captures. More particles, more forces, more layers, waiting to be discovered. And one of the great hopes is that somewhere in some experiment, reality will spring a surprise that does not fit the framework, an anomaly that points the way toward the deeper theory that lies beyond. An impossible particle climbing up through the Earth is exactly the kind of surprise that could be such a signpost. So physicists asked, what could it be if it is something new? One leading idea points to a hypothetical cousin of the ordinary neutrino, a particle sometimes called a sterile neutrino. The ordinary neutrinos come in a few known types, and they have the strange ability to morph from one type into another as they travel, a phenomenon already confirmed and deeply weird in its own right. A sterile neutrino would be a fourth hidden type, one that interacts even more weakly than the others, so weakly that it could pass through the Earth even at the energies that would absorb an ordinary neutrino. The idea is that a high-energy neutrino arriving at the Earth could morph into this ghostly, sterile form, slip through the planet untouched precisely because it interacts so feebly, and then, near the far surface, morph back into an ordinary neutrino and interact in the ice, producing the upward shower. If sterile neutrinos exist, they would be a genuinely new piece of reality, an entire hidden type of particle, and they have been sought in other experiments for years with tantalizing but unconfirmed hints. The Anita events in this picture would be among the first fingerprints of a hidden particle that has been slipping through everything, including you, undetected. What makes the sterile neutrino idea especially seductive is that it builds on something we already know to be true and strange. The ordinary neutrinos genuinely do transform from one type into another as they travel, a confirmed phenomenon that is itself one of the weirdest facts in physics. A particle changing its very identity in flight, becoming a different kind of thing, and then changing back, over and over, as it crosses space. This is not speculation. It earned its discoverers the highest honors, and overturned an earlier picture in which neutrinos were thought to be massless and unchanging. So we already know that neutrinos shapeshift. The sterile neutrino idea simply adds one more form they might shift into, a fourth hidden identity that interacts so weakly it could ghost through the entire Earth, even at energies that would absorb the ordinary forms. A neutrino arriving at the planet could, in this picture, slip into its unhidden form precisely when it needs to pass through the rock, then shift back into a detectable form just in time to announce itself in the ice. It is an elegant possibility, and it would mean that the shape-shifting we have already observed has one more disguise we never knew about, a disguise that lets it walk straight through worlds. But it remains unproven, and the searches for sterile neutrinos in other experiments have produced a confusing tangle of hints and null results, leaving the question wide open. Another set of ideas reaches into the realm of dark matter, the invisible substance that makes up most of the matter in the universe and whose nature remains unknown. What if dark matter particles, gathered in the dense core of the Earth or arriving from space, were decaying or interacting in some way that produced the high-energy particles Anita saw? In some of these models, dark matter would generate exotic particles that could traverse the planet and emerge to make the upward showers, which would mean that Anita had stumbled onto the first direct trace of the dark matter we have been hunting for decades, revealing itself not in a deep underground detector as everyone expected, but in a balloon over Antarctica, in the form of impossible upward bursts. Still, other ideas reach into the deeper theoretical frameworks that physicists have proposed to extend our understanding. Frameworks that predict whole families of undiscovered particles, some of which might be long-lived and weakly interacting enough to pass through the Earth and decay near the surface, producing exactly the kind of signal Anita recorded. Each of these explanations, if true, would be a monumental discovery, a window into physics beyond the known, a first glimpse of a layer of reality we have only theorized about. Pause for a moment on what any one of these would actually mean, because the stakes are easy to state and hard to overstate. If the answer were the sterile neutrino, it would mean there is an entire fourth type of one of the most fundamental particles in nature, a type so shy it has eluded every search, woven invisibly through the universe and through your body, and that Anita had caught its first clear fingerprint. That alone would rewrite the textbooks, would point toward physics beyond our complete theory, would open questions we cannot yet even frame. If the answer were dark matter, it would be even larger. We have spent decades and fortunes building detectors deep underground to catch a single particle of the invisible substance that dominates the universe. And we have found nothing. For dark matter to reveal itself instead in a balloon over Antarctica, in the form of impossible upward bursts, would be one of the great surprises in the history of science. The solution to the largest mystery in cosmology, arriving from the least expected direction. And if the answer were some entirely new particle from a deeper theoretical framework, it could be the first thread of a whole new layer of physics. The loose end that, pulled, unravels into an understanding of reality far richer than the one we have. This is why, for all the skepticism, physicists cannot quite let it go. The prize, if the events are real, is enormous, nothing less than a doorway into the physics that lies beyond our current understanding. The physics we know must exist, but have never been able to see. To find that doorway, you do not look where the light is good. You look where reality is misbehaving, where the data refuses to fit, where something impossible appears to be happening. An anomaly is the most valuable thing in science, precisely because it is the only thing that can point beyond what is already known. A result that confirms the theory teaches you nothing new. A result that breaks it could teach you everything. And so a handful of strange signals from a balloon over the ice, however likely they are to dissolve into some mundane effect, are watched with an intensity out of all proportion to their number, because of what they might, just might, turn out to be. There is a discipline in this that is worth admiring. The physicists working on the Anita anomaly are not credulous dreamers, leaping to declare a revolution. Most of them are sober, cautious, deeply skeptical, fully aware that the smart money is on a mundane explanation, and they say so plainly. But they are also unwilling to dismiss the events prematurely, because they know that premature dismissal has cost science real discoveries in the past. So, they hold the tension, investigating the mundane and the exotic at once, refusing to commit until the evidence forces them to. Buildings balanced to gather better data. It is the scientific temperament at its finest, the willingness to sit with a genuine, uncertainty, to neither overclaim nor dismiss, to chase a strange fact patiently down whatever path it leads, knowing it may end in an anticlimax or in a revolution, and being prepared, professionally, for either. It is worth being honest and clear about the status of all these exotic ideas, because honesty is what separates real wonder from empty hype. None of them is confirmed. Every one of them is speculative, a hypothesis proposed to account for a handful of strange events, and most of them face their own serious difficulties, including that same stubborn problem of why the giant buried detector did not see the companions these particles should bring. The exotic explanations are not answers. They are possibilities, attempts to imagine what could produce such a signal if it is real and genuinely new. And many physicists remain skeptical of all of them, suspecting that the mundane explanation, the trick of the ice, will eventually win out once the effect is fully understood. But the very fact that serious physicists have spent years proposing sterile neutrinos and dark matter and exotic particles to explain these events tells you something important. It tells you that the ordinary explanations did not obviously win, that the events were strange enough and resistant enough, that thinking minds were driven to reach beyond the known framework to account for them. The door to new physics was not flung wide open, but it was not slammed shut either. It remained and remains, unsettlingly ajar. So where does that leave us, standing in front of these two strange events, years after they were recorded, with the world's physicists still unable to agree on what they were? It leaves us holding two possibilities that refuse to collapse into one. And the discomfort of holding them both is, in a way, the truest description of where the science actually stands. The first possibility is the deflating one, and it may well be correct. It is that the Anita events are not new physics at all, but some subtle, mundane effect that we simply have not fully understood yet, a quirk of how radio waves behave in the strange layered ice of Antarctica, a trick of reflection or refraction, or some near-surface effect that mimicked the appearance of an impossible upward particle while being nothing of the sort. In this version, the mystery is real but boring, a puzzle of instrument and environment rather than a window into the unknown, and one day someone will work out exactly how the ice fooled the balloon, and the anomaly will quietly close, and the textbooks will not change. This is, many physicists would say, the most likely outcome, because it usually is. Anomalies usually turn out to be mundane. The smart bet, the historically vindicated bet, is on the boring explanation. But the second possibility lingers, and it cannot yet be ruled out, and that is what makes this story matter. It is that the events are real, that something genuinely passed up through the earth, that our complete and beautiful theory of the particles and forces of reality is missing something, and that Anita caught the faint, fleeting fingerprint of that missing thing, a sterile neutrino, a trace of dark matter, an unknown particle from beyond the edge of the known. In this version, two brief radio whispers over Antarctica are a crack in the foundations of physics, a place where reality quietly broke the rules, and where, if we are clever and patient enough, we might follow the crack down into a whole new layer of the universe. We do not know which possibility is true. We genuinely do not know. And the honest state of the science is that uncomfortable suspension, the refusal of the events to be either confidently explained away, or confidently embraced, the maddening, fascinating not knowing. There is a particular unease that comes from data that defies your complete theory, and it is different from ordinary mystery. We are used to not knowing things, to open questions at the frontier, to gaps in our knowledge that we expect to fill in with more work. But the Anita events are not a gap. They are a contradiction. They are not a place where our theory says nothing. They are a place where our theory says no. This cannot happen, and reality may have answered. Quietly, it happened anyway. This is a rarer and more disturbing thing than ordinary ignorance, and the difference is worth making sharp. There is a vast amount we do not know, and most of it sits comfortably in the category of the not yet explained. Questions our theory simply has not gotten around to answering. Blanks we expect to fill in with more work. We are at peace with that kind of unknown. But the Anita events, if they are real, are not a blank. They are a no that became a yes. They are not a question our theory failed to address, but a question it had addressed clearly and confidently, with a firm answer of impossible, only for reality to seem to contradict that answer to its face. That is a more vertiginous kind of unknown. It is not the unknown of a map with empty regions. It is the unknown of a map that says solid ground, where you have apparently just fallen through. The first kind of ignorance is humbling. The second kind is destabilizing, because it suggests that the parts of the map we were most confident about, the parts marked known and settled and proven, might themselves be wrong. To have your most successful, most precise, most exhaustively tested theory of reality state plainly that something is impossible, and then to find data that looks like that impossible thing occurring, is a profoundly destabilizing experience. It is the feeling of the rule book itself being questioned, not by a philosopher, but by the universe, in the form of a few strange signals from the bottom of the world. And whether those signals turn out to be a trick of the ice or a glimpse of new physics, the mere fact that they could be either, that we cannot yet tell, is itself a humbling reminder of how much we do not understand about the reality we live in. And notice the shape of the unease, because it is the same shape that runs through so many of the deepest mysteries in science. It is not the fear of a danger. The Anita particles, whatever they are, pose no threat to anyone. They are not coming to harm us. The unease is something quieter and more philosophical. The unease of discovering that the world might not work the way we are certain it does, that the solid floor of our understanding might have a thin spot in it, a place where something came through that should not have been able to. It is the unease of an anomaly, a single stubborn fact that does not fit, sitting quietly in the data, refusing to be explained, hinting that the universe is stranger than our theories allow. And history has taught us, again and again, to pay very close attention to exactly that kind of fact. Consider how often a single strange fact, a single thing that did not fit, has cracked open an entire new understanding of nature. The neutrino shell itself, the ghost particle at the center of this whole story, was born from exactly such an anomaly. Early in the study of radioactive decay, physicists noticed that energy seemed to be going missing, that the books did not balance, that some of the energy released in certain decays simply vanished. in apparent violation of one of the most sacred laws in all of physics, the conservation of energy. It was a small, stubborn discrepancy, a fact that did not fit, and, rather than abandon the law, one physicist made a desperate proposal that there was an invisible particle carrying away the missing energy, a particle so ghostly it could never be detected. He apologized for the idea, certain it could never be confirmed. Decades later, the neutrino was found, exactly as the missing energy had demanded. A tiny accounting error in the energy of a decay turned out to be the first whisper of one of the most abundant particles in the universe. Or consider the discovery of antimatter, which began as a strange track in a detector, a particle curving the wrong way in a magnetic field. As though it carried the opposite charge to anything known, it would have been easy to dismiss as an error. Instead, it was the first sign of an entire mirror world of matter. Or consider one of the most important discoveries in the history of cosmology, the faint relic glow that fills all of space, which was first detected as an annoying hiss of static in a radio antenna. A persistent noise the scientists could not get rid of, that they suspected was due to dust, or interference, or even the droppings of pigeons nesting in the equipment. They cleaned everything, checked everything, and the hiss remained, a fact that would not fit until they realized they were hearing one of the most profound signals in all of science, again and again. The thing that did not fit, the anomaly, the stubborn fact, the signal everyone first assumed was an error, turned out to be the doorway to something vast. This is why physicists cannot simply ignore the Anita events, even though the smart bet is that they will turn out to be mundane, because the history of their own field screams at them not to. The anomaly that everyone assumes is an instrumental error is sometimes an instrumental error, and sometimes it is the first sign of a revolution, and you cannot always tell which in advance. The only way to find out is to look closer, to build better instruments, to gather more data, to chase the strange fact down until it either dissolves into a mundane explanation or hardens into an undeniable discovery. And that is exactly what is being done. The story of the impossible upward particles is not over. A new generation of instruments is being built to hunt for exactly these kinds of events, more sensitive, more capable, designed specifically to catch more of them if they are real, and to understand them if they are not. The successor to Anita, a more advanced balloon-borne instrument, is being prepared to fly over the same frozen continent with far greater sensitivity, expressly to investigate the anomaly its predecessor uncovered. This is how science closes in on a mystery, and there is something admirable in the patience of it. You do not resolve a puzzle like this by arguing about it. You resolve it by building a better instrument and gathering more data. The successor is designed from the ground up to be far more sensitive, capable of catching many more of the rare high-energy events, far better able to distinguish a genuine upward particle from a confusing reflection, to pin down the direction and energy and character of whatever it sees. Where Anita caught its strange events almost by accident, while looking for something else, the new instrument flies knowing exactly what to hunt for, with the anomaly itself as one of its central targets. It will drift over the same frozen continent, beneath the same black daytime sky, listening to the same vast expanse of ancient ice, but with sharper ears specifically tuned to the question its predecessor raised and could not answer. And the beauty of it is that any outcome is informative. If it flies and catches a whole population of these upward events, with the energies and angles that make them impossible under known physics, and if those events resist every trick of the ice, then the anomaly hardens into something undeniable, and the hunt shifts decisively toward identifying the new physics behind it. If, instead, it flies and watches and catches nothing where its sensitivity says it should have caught many, that too is a powerful answer. Strong evidence that the original events were some rare fluke or instrumental effect, and the anomaly fades. Either way, the question moves toward resolution, and we, alive in the meantime, get to live in the suspense of a genuine open question at the frontier of physics, in the years before the answer is known. If the upward events are real, if there truly is a flux of strange particles passing up through the Earth, the new instrument should catch many more of them, and with more events in hand, physicists could finally characterize them, measure their properties, and determine once and for all whether they are a trick of the ice or a genuine crack in the laws of physics. And if the new instrument flies and watches and catches nothing, that too would be an answer. Nafar, strong evidence that the original events were some rare fluke or mundane effect after all. Either way, the mystery is not destined to remain forever unsolved. It is an open question with a path to an answer. And a strange fact being Actisophanos, actively chased, and we are alive in the window between the strange observation and its resolution. In the suspended moment, before we learn whether reality broke its own rules over Antarctica, or merely seemed to, that is a remarkable place to be standing, if you think about it. Most of the great anomalies of the past we know only as resolved history, as stories of mysteries that were eventually explained. But this one is live, unresolved, its outcome genuinely unknown even to the experts. No one listening to this knows whether the Anita events will turn out to be a footnote or a revolution. The answer has not been written yet, and there is a particular thrill in that. The thrill of an open case. A genuine mystery at the frontier of physics. The kind of thing that, decades from now, people may look back on as either a curious dead end or the first sign of a discovery that changed everything. Bring it home now, down from the balloon at the edge of space, down from the abstract energies and the exotic particles, to where you are sitting right now. Because the strangeness of the Anita events is not only out there, over Antarctica, it is a strangeness about the ground beneath you, about the planet you are standing on, about the relationship between you and the solid Earth that you have always trusted to be impenetrable. You think of the Earth as solid, as the ultimate barrier, the thing that stops everything, the floor of your entire existence. You cannot see through it. You cannot dig through it. To you, the planet beneath your feet is the very definition of impenetrable 8,000 miles of rock and metal that nothing could possibly cross. And yet, even on an ordinary day, with no anomaly involved at all, the Earth is not the barrier you imagine. Neutrinos are passing up through it constantly, streaming from the sun, going through the planet, and out the other side, which means that right now, beneath your feet, particles are traveling upward through the entire Earth and emerging from the ground, all around you, harmlessly, invisibly, all the time. The solidity of the planet is, to these ghostly particles, an illusion, the same illusion as the solidity of your own body. which they also pass through without resistance. You are not as solid as you feel, and neither is the world. Both are mostly empty space to the right kind of particle, and the right kind of particle treats the entire planet as a window. The Anita Ents take that already strange truth and push it past the breaking point. They are not just particles passing through the Earth, which is strange but known. They are particles that should not have been able to pass through the Earth, doing it anyway, and at energies that should have made it impossible. They are the ordinary wrongness of a transparent planet, amplified into an extraordinary wrongness, a violation not just of intuition but of the rule book itself. And they emerged from the ground. They came up. There is something that lodges in the mind about that direction, up out of the earth, because everything in our experience tells us that the ground is where things end, where things are buried, where things are stopped. Stop, not where things emerge from carrying impossible energy. The image of a particle climbing up out of thousands of miles of solid planet and bursting into the air is an image turns the solid world porous that makes the floor of reality feel for a moment like a screen door with the unknown passing freely through it from below. We build our whole sense of safety on the solidity of the ground. From the moment we are born, the earth beneath us is the one thing that does not move, does not yield, does not betray. We bury what we want gone in the ground, confident it will stay. We build on the ground, confident it will hold. The very word grounded means stable, certain, safe. And beneath that confidence lies an unspoken assumption, so deep we never examine it, that the ground is a barrier, a floor, a thing that separates us from whatever lies below and keeps it there. The Anita events whisper that the assumption is not quite true, that the floor is more porous than we believe, that things can come up through it, even things our physics says should be impossible. It does not threaten us physically, but it unsettles something deeper than physical safety. It unsettles the primal sense that down is solid and final, that the ground is a wall and not a window. To imagine an impossible particle climbing up through thousands of miles of rock and bursting out beneath the open sky is to feel for a moment the solidity of the world go thin, to sense the vast dark interior of the planet not as a sealed vault, but as something the universe can reach into and out of, carrying things we do not understand. And it raises a quiet question that is hard to shake. If this happened twice, caught by chance by one instrument, watching one small patch of ice for a limited time, how often is it really happening? How many impossible particles are passing up through the earth and bursting out of the ground, everywhere, all the time, unseen, undetected, simply because we did not happen to have an instrument watching that spot at that moment. The two Anita events might be the only ones, freak occurrences, or they might be the rare visible tip of something happening constantly, all over the planet. Beneath every field and city and ocean, a steady rain of the impossible, going the wrong way, up instead of down, that we have only just barely begun to notice. We do not know, and the not knowing means that the strangeness is not safely contained to one experiment over one frozen continent. It is potentially everywhere, including here, including now, including the ground directly beneath you, which may be at this very moment, allowing things to pass up through it that our deepest theory says cannot exist. This is the quietly expanding horror of an anomaly like this, the way it refuses to stay contained. If it were a single freak event, you could file it away as a curiosity, a one-in-a-trillion fluke that happened once and will never happen again. But it was not once. It was more than once, caught by an instrument that watches only a tiny sliver of the world, for only a tiny sliver of time. And the moment you realize how little Anita was actually watching, the question changes shape and grows teeth. Anita saw a small patch of ice on occasional flights for a few weeks at a time. The Earth is enormous. The years are long. If something impossible passed up through the ground twice in that minuscule window of observation, then either we were extraordinarily lucky to catch the only two events that will ever happen, which strains belief, or these things are happening far more often than we know, all over the planet, beneath the oceans and the cities and the empty deserts, an unseen traffic of the impossible flowing up through the world, of which we have glimpsed only the barest fraction, because we only just barely happened to be looking. We do not know which, and the second possibility, that the ground beneath everyone, everywhere, all the time may be quietly passing things our physics forbids, is the kind of thought that, once you have had it, is difficult to set back down. It is worth sitting, too, with what this whole episode reveals about the state of our knowledge, because it is humbling in a way that is easy to miss. We possess, in our theory of particles and forces, one of the greatest intellectual achievements in human history, a description of reality so precise that it can predict the behavior of subatomic particles to a dozen decimal places, a triumph of the human mind that took generations to build. And yet here is a handful of strange events that this magnificent theory cannot comfortably explain, that sit at its edge and will not be tamed. The very existence of such an anomaly is a reminder that even our finest theory is not the final word, that it is a map extraordinarily detailed and accurate over the territory we have explored, but a map with edges, beyond which lie regions we have not charted. We have good reason to believe those uncharted regions are real and not small. Our complete theory of particles and forces, for all its triumphs, leaves enormous questions unanswered. It does not explain the dark matter that vastly outweighs all the ordinary matter in the universe. It does not explain the dark energy that dominates the cosmos and accelerates its expansion. It does not fold gravity into the same framework as the other forces. It does not explain why the particles have the precise masses they do, or why there are exactly the families of them that there are, or why matter so overwhelmingly won out over its mirror, antimatter. These are not minor footnotes. They are gaping holes, and they are clear evidence that our theory, however precise within its domain, is a piece of a larger picture we have not yet seen. Physicists are not hoping for new physics out of idle curiosity. They are certain it must exist, because the theory we have, magnificent as it is, simply cannot be the whole story. Somewhere there are more particles, more forces, more layers, and the great hope is that reality will leave a clue, an anomaly, a place where the incomplete theory visibly fails, pointing the way toward what lies beyond. That is the deepest reason the Anita events command attention out of all proportion to their number. They are exactly the kind of clue physicists are watching for. a place where the data seems to defy the complete theory. A possible fingerprint of the missing physics we know must be there. The odds favor a mundane explanation, yes, but the prize, if the odds fail, is a glimpse past the edge of the map, into one of those uncharted regions we are certain exist and have never been able to reach. The Anita events may be a smudge on the map, an error in the drawing, or they may be the first hint of a coastline we did not know was there. The edge of a continent of new physics, glimpsed faintly from a balloon over the ice, and we cannot know from where we stand now which it is. That is perhaps the hardest and most honest thing to sit with. We are accustomed to stories that resolve, to mysteries that get solved by the end, to the satisfying click of an answer falling into place. But real science, lived from the inside, is full of long stretches where the answer simply is not known, where a strange fact hangs in the air for years, neither confirmed nor refuted, while the slow work of investigation grinds forward. The Anita anomaly is in one of those stretches right now, and it may remain in one for a long time yet. There is no resolution to offer you tonight, no neat ending, no final verdict, because none exists. There is only the strange fact itself, the faint signal coming up from the ice, the closed box of the contradiction, the silence of the buried detector, the careful arguments on every side, and the genuine, unresolved, ongoing not knowing. And rather than find that frustrating, you can find it, if you choose, strangely thrilling, because an unresolved mystery is a door still open, a story still being written, a question whose answer no one yet possesses, including the cleverest minds alive. To stand inside an open question of this magnitude is a privilege, even when, especially when, the question has no answer yet. There is something fitting, almost poetic, about where this all happened. Antarctica is the most alien place on Earth, the closest thing our planet has to another world. It is a continent buried under miles of ice, a frozen desert larger than Europe, where the temperatures fall to depths that would kill an unprotected human in minutes, where the wind screams across endless white emptiness, where for months at a time the sun never rises, and the only light is the cold shimmer of the stars and the aurora. It is a place so hostile, so empty, so far from everything, that it feels less like part of our world and more like a doorway to somewhere else. And it was here, above this frozen edge of the planet, in the thin, cold air at the boundary of space, that an instrument caught the impossible coming up out of the ground. Picture the scene. A balloon the size of a stadium, filled with helium, drifting at the very top of the atmosphere, nearly 40 kilometers up, so high that the sky above is black even in daytime, and the curve of the Earth is visible below. Hanging beneath it, a cluster of antennas listening. Below that, the vast white expanse of the ice sheet, stretching to every horizon, silent and ancient and still. The balloon drifts on the polar winds, circling the bottom of the world, carried by the great vortex of air that swirls around the pole, listening day and night to the faint radio whispers of the cosmos. The physicists who built it are far away, in research stations and laboratories, watching the data stream in, most of it the expected hiss and crackle of cosmic rays and reflections. And then, buried in that data, two signals that should not be there, two whispers coming up from the ice instead of down from the sky, two fingerprints of the impossible, recorded by a balloon over the loneliest place on Earth, and not fully understood to this day. It is hard to overstate how otherworldly the setting is. Antarctica in the long polar night is perhaps the closest a person can come, without leaving the planet, to standing on the surface of another world. The sun does not rise for months. The cold is beyond anything human bodies are built to endure, deep enough to freeze exposed skin in moments, deep enough that the air itself seems to bite. The landscape is not landscape in any ordinary sense. No trees, no soil, no features, just an endless plain of ice stretching white and featureless to a horizon that offers nothing. Under a sky that in the dark months is filled with stars of a brilliance no city dweller has ever seen, and sometimes with the eerie green and violet curtains of the aurora rippling overhead. It is silent, vast, and utterly indifferent to human life, a place that does not want us there and tolerates us only briefly and grudgingly. And it is precisely this hostility, this emptiness, this profound isolation from the noise and warmth and clutter of the inhabited world that makes it perfect for listening to the universe. The very qualities that make it deadly to life make it ideal for science. To catch the faintest whispers from the cosmos, you must go to the quietest, emptiest, most lifeless places, and there are few quieter or emptier or more lifeless than the high ice of the Antarctic plateau under the polar dark. There is a long and noble tradition of human beings going to the most extreme and desolate places on the planet to listen for the secrets of the universe, and it speaks to something deep in us. We build detectors deep in mines and inside mountains to hide from the noise of the world. We carry instruments to the dry, high deserts and the frozen poles, to the places most hostile to life, precisely because those places are quiet enough, clean enough, empty enough to hear the faint signals of the cosmos. There is something moving about that, the image of our species dragging its most sensitive instruments to the ends of the earth, to the bottom of the world, to the edge of space, all to catch a few faint whispers from the dark, a few ghostly particles, a few hints of how reality really works. And sometimes, as with Anita, what we hear in those silent places is not an answer, but a deeper question. A signal so strange it sends us back to our theories, wondering if we understood anything at all. And consider the staggering imbalance between the smallness of the signal and the size of what it might mean. What Anita recorded was nothing dramatic to the senses. No flash, no roar, no visible event. It was a faint pattern in radio static, a brief electromagnetic whisper, lasting a tiny fraction of a second, the sort of thing that exists only as a wiggle on a graph, a blip in a stream of data, utterly imperceptible to any human standing right there beneath it. And yet that faint wiggle, if it is real, and if it is what it appears to be, could carry implications that reach to the very foundations of physics, could announce a new particle, a new force, a crack in the deepest theory we have. There is something profound in that disproportion, the way the largest truths can hide in the smallest signals, the way a whisper can carry news that would shake the world. It is a reminder that the universe does not announce its secrets with fanfare. It murmurs them faintly, in the language of subtle measurements, and it falls to us to build instruments delicate enough to hear the murmur and minds careful enough to understand what it might be saying. The revolution, if it is a revolution, did not arrive with thunder. It arrived as a blip, twice over the ice, almost too faint to notice at all. It is no accident that a mystery like this takes hold of the mind most powerfully in the quiet, in the dark, in the late hours when the busy noise of the day has fallen away. In daylight, the idea of impossible particles climbing up through the earth is an abstraction, a curiosity easily set aside amid the demands of ordinary life. But at night, when the mind is free to wander out toward the edges of what is known, the strangeness can be felt more fully. The unease of a world that might not work the way we are certain it does. The disquiet of a solid planet that might be quietly porous to things we do not understand. The vertigo of a theory so successful, and yet, perhaps, not quite complete. These are the thoughts that find us in the dark, and they can be frightening, but they can also be something else, something better, if we let them. Because the right way to meet a mystery like this is not with dread, but with a kind of alert and open wonder. The Anita events are not a threat. Whatever they are, a trick of the ice, or a glimpse of new physics, they harm no one, they endanger nothing. What they offer is not danger, but the far rarer gift of genuine, unsolved mystery. A real question at the frontier of human knowledge, the kind of question that reminds us that the universe is not a closed book, that there are still things out there we do not understand, still surprises waiting in the data, still doors we have not opened. To live in a universe that can still surprise its most careful observers, that can still send a signal so strange it divides the experts and resists every explanation for years, is to live in a universe that is still deeply, wonderfully mysterious. And that is not a cause for fear. It is a cause for awe. And there is a specific kind of awe available here that is worth naming, because it is rarer than the awe we usually feel about space. We are used to being awed by the vast, the bright, the violent, exploding stars and colliding galaxies and the immense scales of the cosmos. But the Anita anomaly offers a different and subtler awe, the awe of the unexplained, of a fact that sits quietly in the data and will not yield to our finest theories. It is the awe of standing at the exact boundary of human knowledge, at the place where what we understand runs out, and what we do not begins, and feeling the edge of it directly. Most of us go through life with the comfortable sense that someone, somewhere, understands how everything works, that the experts have it figured out, that reality is fully mapped, even if we personally have not seen the map. The Anita events are a reminder that this is not so, that even the experts, even the people who have devoted their lives to understanding the fundamental nature of reality, can be confronted with a handful of signals from the bottom of the world and be unable to say what they were, to feel that, to really feel that the edge of human understanding is right there, close enough to touch in a few strange whispers over Antarctica, is a profound and humbling and oddly beautiful experience. It is the awe not of the universe's size but of its mystery, the awe of how much remains genuinely unknown. So, gather it all together now, the whole strange story, and let it settle as the night deepens. High above the frozen bottom of the world, an instrument built, listen for listen, ghostly particles from space caught something coming the wrong way. Twice, years apart. It recorded what looked like air showers rising up out of the Antarctic ice, climbing into the sky, carrying a fingerprint that meant they had not bounced off the surface, but had come directly from below. from inside the Earth. The steep angle of their arrival meant they had crossed thousands of kilometers of solid planet to get there, and the energy they carried meant it that the only particle capable of crossing the Earth at all, the ghostly neutrino, should have been absorbed long before completing such a journey. By our complete and exhaustively tested theory of reality, the particles that made those signals should not have been able to do what they did. They should not exist, or, at least, they should not have arrived the way they did. Scientists have spent years trying to explain it, and the explanations have struggled. The mundane answers, the tricks of the strange layered ice, have not cleanly accounted for the events. The exotic answers, the sterile neutrinos, and dark matter, and unknown particles have faltered against the silence of the giant detector buried in the same ice, which should have seen their companions and saw nothing. The anomaly is squeezed from both sides, too strange to be easily ordinary, too lonely to be easily exotic, sitting in a gap between explanations, refusing to resolve. And so it remains, one of the genuine unsolved puzzles of modern physics, a handful of strange signals from the edge of the world that might be a quirk of the ice, or might be the first faint crack in the foundations of everything we think we know. We do not know which it is. That is the honest truth, and it is worth holding on to because it is rarer and more precious than it sounds. Think for a moment about what it must have been like to be the person who first noticed those events in the data. To sit in front of years of recordings, most of them the expected hiss and crackle of cosmic rays, and to find, buried among them, a signal that should not be there. A whisper coming up from the ice instead of down from the sky, carrying a fingerprint that meant the impossible. To check it and recheck it and fail to make it go away. To bring it to colleagues, half expecting to be told you had made an error, and to watch them fail to explain it too, with precursors. There is a particular vertigo in that experience. The vertigo of suspecting, however, cautiously, that you may be looking at something genuinely new, that the universe may have just shown you a corner of itself that no one has ever seen, while knowing full well that it is far more likely to be a subtle mistake you simply have not found yet. To live in that suspension, neither dismissing nor believing, holding the possibility open while hunting relentlessly for the mundane explanation, is the daily reality of the people who work at the frontier of physics, and it is a kind of quiet courage we rarely think to honor, the willingness to sit with a profound uncertainty and chase it patiently for years toward an answer that may never come in your lifetime. That is the human heart of this story, beneath all the physics. A few people, in the cold and the dark and the data, caught something they could not explain, and rather than look away, they have spent years trying to understand it, building better instruments, proposing and discarding ideas, arguing and checking and refining, all to answer a question that most of the world has never even heard of. The impossible particles over Antarctica are, in the end, a monument to that impulse. The refusal to leave a strange fact unexplained, the willingness to chase a whisper from the edge of the world wherever it leads, and whether it leads to a loose cable or a new law of nature. The chase itself is one of the most admirable things our species does. We are alive in the strange and lovely moment before the answer arrives. We live in an age that often feels as though everything important has already been discovered. as though the great mysteries are settled and only the details remain. The Anita events are a quiet rebuke to that complacency, a reminder that the universe is still keeping secrets, that even our finest theories have edges, that something can come up through the solid earth and burst into the air over Antarctica and leave the world's physicists genuinely unsure what they have seen. Whether it turns out to be a mundane effect, finally understood, or a doorway into new physics, the mere fact that it could be either, that we cannot yet say, is a sign that the long human adventure of understanding reality is nowhere near finished, and there is nothing in any of it for you to fear. The particles, whatever they are, mean you no harm. They have been passing through the earth and through you, in one form or another, for the entire history of the planet, gentle and invisible and harmless. The mystery they pose is not a danger but a wonder, a genuine open question hanging at the frontier of knowledge, the kind of thing that, if you let it, can fill you not with dread but with a quiet, expansive awe at how strange and unfinished and full of secrets the universe still is. The crack in the rule book, if it is a crack, threatens nothing in your life. It threatens only our certainty, and a little humility about the limits of what we know is no bad thing to carry into the dark. So let the strangeness become something gentle now, as you settle toward rest. Somewhere over Antarctica, the ice is silent under the stars, and the experiments continue. And somewhere in the data, or in the data yet to come, the answer is waiting. Whether it is a trick of the ice or a glimpse of the unknown, you do not have to solve it. You do not have to decide whether reality broke its own rules at the bottom of the world. You can simply let it be what it is. One of the genuine open mysteries of our time. A few strange whispers from the frozen edge of the planet, glowing quietly in the great unfinished story of everything we are still trying to understand. The particles will keep passing through the earth and through you as they always have, harmlessly, silently, while you rest. And the question of what came up through the ice will keep waiting, patiently for the instruments and the minds that will one day finally answer it. Lie back and let the mind rest on the strangeness of it without straining to resolve it, the way you might rest your eyes on a distant horizon. There is a particular peace available in an unsolved mystery if you can let go of the need to solve it. We are so trained to want answers, to feel uncomfortable with open questions, to reach for resolution, that we forget there is also a deep and quiet pleasure in simply standing before something genuinely unknown and letting it be unknown. The Anita events are exactly that, a genuine unknown, not yet resolved, perhaps not resolvable for years to come. And rather than gnawing at it, you can simply rest in the wonder of living in a universe that still contains such things, that can still produce a signal so strange that the cleverest people alive cannot agree on what it means. Think of all the people, right now, working on this quietly, patiently, across the world. The physicists poring over the old data, running the analyses again, testing one more possible explanation. The engineers building the next instrument, more sensitive than the last, preparing it to fly over the ice and listen for more of these impossible whispers. The theorists scribbling out models of sterile neutrinos and exotic particles, imagining what could possibly produce such a signal. None of them knows the answer. All of them are reaching toward it in the patient, collective, generations-long way that science reaches toward everything, each one adding a small piece, none of them certain to see the resolution in their own lifetime. There is something deeply human and deeply moving in that, the willingness to chase a strange fact down for years, for decades, simply because it is there, simply because the universe presented us with a puzzle, and we cannot bear to leave it unsolved. And one day, the answer will come. Maybe it will be the deflating one, the trick of the ice finally understood, and the anomaly will quietly close. A footnote in the history of a balloon experiment over Antarctica. Or maybe it will be the extraordinary one, the confirmation of a new particle, a new piece of reality. And these two strange events will be remembered as the first faint sign of a discovery that reshaped physics, the place where the rulebook first cracked, glimpsed from the edge of space over the frozen pole. We do not know which, but the answer is out there, waiting, in the data yet to be gathered, in the instruments yet to fly, in the minds yet to have the right idea. And we are alive, in the strange and lovely moment before the answer arrives, in the suspended hush between the question, and its resolution, which is, when you think about it, one of the most interesting places a curious mind can ever be. So let the question rest now, unanswered the way it truly is. You do not need it answered tonight. The ice will keep its secret a little longer. The particles will keep passing through the earth, up and down, seen and unseen, as they always have. The balloon experiments will fly again over the silent white continent, listening for the impossible. And somewhere in the years ahead, someone will finally understand again what came up through the ground at the bottom of the world. But not tonight. Tonight, there is only the mystery itself, quiet and strange and harmless, a few whispers from the edge of the world, and you, here, safe and warm, free to wonder at it, and then to let it go. Let your breathing slow. Let the strangeness settle into something soft. The earth beneath you is ancient and vast, and full of secrets, and things are passing through it even now, gently, invisibly, harming nothing as they have since long before you were born and will long after. The universe is stranger than our theories allow, and that is not a threat, but a wonder. A reminder that there is always more to discover. Always another door. Always another whisper from the dark waiting to be understood. You are a small, curious creature in an enormous and mysterious cosmos, and you have spent this night looking for a while at one of its genuine unsolved riddles, a thing that came up through the world and should not have. And now you can set it down and rest and let the great patient work of understanding go on without you while the ice lies silent under the stars, and the impossible particles, whatever they are, keep their quiet passage through the heart of the sleeping earth.